The Earth is endowed with abundant liquid water. So much water, in fact, that if all of it was poured on the 50 United States, they would be covered to a depth of about 90 miles. And yet, the fresh water needed to sustain human life is exceedingly rare. Because nearly the entire water supply of our planet consists of salt water, which cannot be directly consumed or used for irrigation. In one important aspect, the behavior of water is steadfast. The total amount of water neither increases or decreases. Virtually all of the water on the Earth today has existed since our planet was created, testifying to its immense stability. But for the most part, water is a restless substance and undergoes continual transformations from solid to liquid to gas. And as a result of this process, tiny amounts of precious fresh water are formed from the salt water. It is by the process of natural distillation, called the water cycle or hydrologic cycle, that fresh water is derived from the salty waters of the ocean. This cycle begins when the heat from the sun causes the salt water in the oceans to evaporate, forming water vapor, a process which leaves the salts behind. Because of the vastness of the seas, it may take a water molecule 2,000 years to enter this active evaporative phase of the cycle. The atmosphere holds this water vapor, creating clouds. As the clouds cool, the purified water falls as rain or snow. Most rain or snow falls back into the oceans, but some falls on the land, forming lakes and rivers, and then flows back into the seas to complete the cycle. An extra benefit of the hydrologic cycle occurs because the energy of the sun physically lifts water to a higher elevation by evaporation. And the water achieves the potential for giving this energy back. Potential energy is converted to kinetic energy as the water rushes back to the sea. Humans have tapped this resource and converted water's kinetic energy into mechanical and electrical energy to serve the needs of civilization. The history of human beings, like the face of the earth itself, has been shaped by the hydrologic cycle. People have always settled where there is abundant fresh water for drinking and irrigation, and for industry and sanitation. Taken together, the oceans, glaciers, and ice caps contain 99.35% of our planet's water. The remaining 2/3 of 1% make up all the other manifestations of water, from the mighty lakes and rivers to the underground aquifers, atmospheric vapor, swamps, and puddles. Today, the number of human beings is well in excess of 5 billion. The population of the Earth has increased several 100% in this century alone. This huge increase has had a great negative effect both on the availability of fresh water and on the multitude of creatures who depend on it. It should be apparent that the demand for fresh water often becomes critical, and that the topic of water pollution is of extreme importance as we approach the 21st century. Let us learn more about the world of fresh water by following an imaginary stream from its origin on a high mountain peak as it slowly travels back to the ocean. By doing this, we will gather information about freshwater creatures and understand how they're impacted by the forces of pollution. Here on the Continental Divide, water vapor formed by evaporation from the oceans, from surface water, and from the process of transpiration which occurs in plants, join forces to form the clouds which produce snow. This snow will form the snowpack, which millions of people depend upon for a steady supply of water throughout the hot, dry summer months. In June, as the snow melts, living things begin to show signs of life, even in this harsh climate over 2 miles above sea level. A snow-fed spring provides moisture for nearby water-loving plants, and also harbors larvae of the caddisfly. Yet in the seemingly pure mountain world, potential problems exist. Clouds of water vapor can become contaminated with a variety of pollutants. Byproducts of combustion caused by coal-burning power plants and automobiles are the biggest source of these pollutants. Much of the world's coal supply contains sulfur compounds, which combine with the oxygen in the air when burned. These oxidized sulfur compounds react with water vapor to form highly corrosive sulfuric acid in the clouds. Automobile emissions also form dangerous chemicals, including nitric acid, which can equal sulfuric acid in corrosive strength. When the acid-containing clouds condense, acidic rain or acidic snow can occur. This deadly phenomenon has resulted in the destruction of huge areas of forest and has poisoned even high-altitude lakes to the point that both fish and amphibian populations have been entirely wiped out because they are unable to live in water which possesses such powerful acidity. The result is the formation of biologically dead lakes. The Black Forest in Germany and certain areas of Scandinavia have suffered enormously. The problem is also serious in the northeastern area of the United States, where American pollution has also spread to Canadian forests. Many power plants have installed expensive scrubbers to remove dangerous pollutants, and new cars contain pollution control devices, but none are completely effective. Intricate food chains exist in fresh water, which are important to understand in order to appreciate the effects of pollutants. As in the seas, animals which dwell in fresh water rely ultimately on food producers for nourishment. In fresh water, most food producers are tiny algae, which exist as simple unicellular organisms called diatoms. As long chains of filamentous algae, or as thin films on various surfaces. These primitive plants trap the energy of sunlight and convert it into biologically useful food materials in a process called photosynthesis. Water and carbon dioxide are consumed during photosynthesis, and food and oxygen are produced. The primary food consumers, those which convert plant material into animal tissue, can be miniature protozoa, like this amoeba, seen trapping diatoms for food. Filter feeders, like this rare freshwater moss animal who feeds by creating powerful whirlpools in the water. Or grazers, like tiny snails who feed on algal films with their rasp-like tongues. Those fish classified as browsers who nibble at aquatic plants are also primary food consumers. Aquatic animals which feed on the primary food consumers are classified as secondary food consumers, and most of these are predators. Predators consume food which exists in the form of living animal tissue. This group includes many fish, some turtles, and larger aquatic animals like alligators. Also dependent on the cycle of freshwater food production are birds, who live on or near the water's surface. Some, like ducks and swans, will eat both animal and plant material. But others, like egrets, are only predators feeding mostly on fish. And still others are scavengers, cleaning up the remains of dead animals. Living along the bottoms of lakes and streams are deposit feeders, consisting mostly of bacteria. Bacteria are decomposers, converting organic waste into nutrients which dissolve in the water and hence provide fertilizer to aquatic plants, thus completing the cycle of food production and consumption. Undisturbed in nature, this system works perfectly. But when pollutants are introduced into this natural cycle, problems rapidly occur and increase in intensity as the mountain stream descends to lower elevations populated by farms and cities. Let us examine a few categories of pollutants in detail. The first type acts by adding excess nutrients to the water. Examples are fertilizers, sewage, animal waste, and most detergents. All of these nutrients cause algae in the water to grow rapidly, which results in the water becoming overpopulated with these primitive plants. As the algae population becomes overcrowded, it begins to die off, and bacteria which decompose the dead plants rapidly multiply. As a result of this process, the bacteria consume enormous amounts of dissolved oxygen. Eventually, the water can become so oxygen deficient that the animals in the water begin to die off. Fish who derive dissolved oxygen from the water with their gills are especially susceptible to this process. And naturally, if the fish die off, so will the birds and reptiles who feed on them. Sewage is a major water pollutant worldwide. In addition to adding nutrients to water, untreated sewage creates a dangerous health threat by providing a means of transmission for certain diseases, including dysentery, polio, cholera, and hepatitis. Sewage processing plants are required throughout the United States, but they don't solve all the problems. This water pouring from a sewage treatment plant in a large American city clearly contains enormous quantities of detergents, which create huge billows of suds in the river. These detergents will remain in the water unless they are of the biodegradable type, which can be broken down into harmless chemicals by bacteria. If detergents are of the non-biodegradable type, the phosphorus-containing chemicals they employ act as nutrients to algae and result in similar problems of oxygen depletion in the water, as we witness with fertilizer contamination. Sewage plants also do not treat farm waste. A single cow produces as much waste every day as 22 people. And agricultural fertilizers flow undisturbed into our water systems, providing nutrients which increase algal growth. As a result of enormous increases in population, it is apparent that humanity will continue to require the vast quantities of relatively inexpensive food that modern agriculture provides. However, new approaches to farm waste treatment are currently under investigation in an attempt to avoid further contamination of fresh water, which is just as essential to human survival as food. Another category of destructive pollutants are the poisons employed in farming, around the home, and in industry. These include the pesticides, which kill animals, and herbicides, which kill plants, as well as cancer-causing chemicals, organic solvents, acids, oils, and metals. A pesticide which will kill insects on land will generally kill them in water as well. As a result, the delicate chains of food production and consumption can once again be disrupted, causing decreased populations of fish, birds, and other aquatic creatures. Likewise, herbicides which can kill land plants will sometimes kill aquatic plants. But in addition to being destructive to food chains, both herbicides and pesticides can be directly poisonous to humans if they find their way into water supplies. It is not uncommon to find even deep wells polluted with dangerous chemicals. Since much of our country derives its drinking water from rivers and lakes, it is important that poisonous chemicals not be allowed to enter these water supplies from any source. Another major source of water pollution is from industrial chemicals. These can include highly dangerous cancer-producing compounds like dioxins, or foul-tasting organic solvents, or oils which coat the surface of the water, preventing oxygen absorption, and metallic poisons such as lead and cadmium from mines and foundries. Factories can also dump strong chemicals into rivers, which disrupt acid balances, just as we have seen with acid rain. We have made great strides in the United States in dealing with water pollution, but we still have a long way to go before the river, which began high in the mountains, returns back to the sea in a condition uncontaminated by the wastes of human civilization. The degree of water pollution tends to be very much worse in much of the rest of the world, especially in the developing countries where maintaining pure water is low priority compared to increasing industrial output. Pollution is no respecter of political boundaries, and for this reason, worldwide solutions are required to this very serious problem. We may wish to become involved in working to bring about an end to water pollution if we begin to see ourselves as forming a natural link in the hydrologic cycle. We drink several liters of water each day to replenish losses occurring through the natural processes of the body. Some of the fresh water taken into our bodies finds a temporary home inside of our cells, where it provides the internal medium for the essential biochemical reactions which take place there. Water transports food materials into cells and dissolves waste materials passing out of cells. And some water will become the liquid constituent of blood and lymph. The human body becomes integrated into the hydrologic cycle in this way. The water passing from sea to clouds and rain to waterfall flows through our bodies and those of countless numbers of other creatures, creating a river of life which sustains us all.